Thank you for the introduction. I have prepared actually 3 presentations because I wanted to introduce the context, then show you in general what we do, and then to show you in detail what we do. But after seeing the previous presentation, what Ján was showing, it feels like we are addressing exactly the same pain points. We already do have some approach to solve them. We are on the way to having the solutions ready. I will improvise a little during my presentations. There are more of them. So I will just go very quickly through the context, because being on at the Faculty of Architecture, I thought I will go through some theoretical background and the history of who I am and why am I talking about these things. Just to give you a general overview, throughout my entire career, I've been working in the paradigm of the computational design architecture that is digital. And curiously, one of my first theoretical introductions into that was actually the PhD thesis by Ján Pernecký, which was an overview of the discipline at that time when he was graduating. And another one was a book by Martin Uhrik. So in this context, it kind of makes sense to talk about the discipline of what is digital in architecture. Usually when I'm talking to people who don't know what the computational design is, or parametric or digital architecture, I try to explain it this way. Or there is a short version of this whole thing. In conventional design process, the architect designs the building. In the computational design process, the architect first designs a piece of a software that then second-hand designs the building. What it means in practice is that in the conventional process, you go through, you start with an assignment, you come up with a concept, you make the first version of the design, then it reiterates and you generate the second, third, and fifth version of the design until you are finished, and then you put the design into production. In the computational design, it's slightly different. You start with an assignment and a concept, then you collect a lot of data. You create a piece of software that sometimes is specifically dedicated or designed for that individual project. It takes some time. It's a big piece of this diagram. Then it takes some computational time, and you come up not with one version, but with many versions. With those versions, you can pick the ones that you like, maybe one, maybe more, and you can put them into production. And another thing is that you can generate any sort of outputs that are needed in the fabrication process. So, for example, it could be a 3D printed building. You don't need to have those 2D blueprints that you usually have. You can have any sort of data that is then processed further automatically. This is the part that I will go through very quickly. I will just explain. I recognize several levels of automation or approach to the digital architecture. One is just a pure automation of something that you would otherwise be able to do manually. Then there is a parametric design where you actually create something that is new, something that would be very difficult to create without the use of computers, but still you would be able to do that. So for example, you do some paneling where you have self-similar panels that differ from one another based on where they are. You would be able to do this manually. It would just take too much time and effort. When it becomes interesting for me is the generative design, where there is the phenomenon of emergence. Something new emerges from the design process. What you see here is a simulation of a swarm that is behaving somehow. And the only thing that I designed is the behavior of the swarm. Then I run the simulation and it generates some sort of a form that is completely deterministic. I know exactly why this happened, but I didn't know upfront it's going to look like this. So there is a meaning in this, but I had no idea upfront. I roughly knew that this sort of design will come out of that, but I didn't know it's going to be this. So this is when the digital approach the computational approach becomes interesting for me as an architect, or this is also, I believe, interesting for the artists. Throughout my endeavors in the computational design, I believe that the emergence can be achieved mainly by simulating something that is smooth and fluent or continuous. This is the first two pictures. They come from Greg Lynn's book, explaining how does the approach to geometry change, where you have the first degree geometry where there are circles and the circles are similar at any given point. The tangent is always the same, and it doesn't really change depending on where you analyze the curve. Whereas when you smoothen the curve, you get something that is called a spline, and the spline is different at every single position, and the difference is determined by what comes before and what comes after, which brings the temporality, the time aspect to the design. And this is something that has been pursued by architects in the late 90s and early 2000s, but kind of became obsolete, and or it never met the expectations or promises that it had. And for me, this was super interesting for quite a long time, until we decided that we should, in the group that we formed before, we decided that we should also explore another approach that was emerging at the time in early 2010s or 2010 and 2020, which is called the discrete approach, represented by Jill Retzin, where he took the same curve and discretized it. By discretization, I mean dividing it into elements that are rigid. You know where do they start, where do they end, and you can basically create similar forms, but out of a finite number of elements that you aggregate in a certain way. So I will just give you a couple of images of what is the continuous approach and what is the discrete approach. Very quickly, through one of my own projects. This was again a group project called Misbehaved, but this so multiple authors designed certain pieces of jewelry. This is a ring. This is a photograph. This is now the rendering of a ring that emerged from a swarm behavior. And we started this project because it's easier to design something as small as a ring, and it's much easier or more approachable than designing a house in this way. That is the continuous approach that we had. At a certain point in early 2020, we abandoned that, and at the studio Subdigital that we had at the time, we started developing a new software called Monoceros. I will very briefly talk about Monoceros because it was the beginning of what is happening right now. Monoceros is a discrete toolkit, discrete modeling toolkit, where the overall design is built out of smaller discrete parts that were called modules at that time. But it brings along a new concept when it comes to the design process, and it is usually even in conventional design, even in the digital design, we start by designing the positives. So we start from a clean slate, and we have certain intentions, we identify opportunities, we design features, we bring in ideas and requirements and so on. So these are the positives, these are the things that we really do want to have in the project, and we try to embed them into the project. With a different approach, it would be that we know the negatives as well. So we know what are the limitations, what are the decisions that are made, what we do not want, what are the capacities, where are the limits, what are the intentions that are negative, something that we do not want, where the possibilities end, what are the regulations that give us certain constraints, and so on. So if you if you look at these, at the map of things that we usually make, so we have certain automatic tools that generate architecture for us, and those tools, they generate the positive things, but we can also design those negative things. So in other words, we set the boundaries to the automaton that then generates the output. And we can, in other words, we can harness an autonomous tool, an animal that is creative or generative, which is the computer, and we give it certain boundaries. Don't go there, don't do that. Just do whatever you want within these boundaries. So what I'm proposing here is an approach where you design the boundaries and let the computer, the tool, the automatic tool design within those boundaries. And that's what Monoceros was doing at that time. It's a mythical animal that cannot be captured and so on. But basically, how does it work? You design certain modules, those are those small discrete parts that can be aggregated, put together, that create a larger whole, which is the positive. This is something that you design, this is something that you want. And then you design certain limitations. In this case, they are called slots and rules. It doesn't really matter, but these things basically tell you where do the possibilities end. And then there is the process, which is quite interesting in the approach, and I don't really have that in this presentation, but I will tell you briefly what does it do. It doesn't start with a clean slate. It doesn't start with an empty site. It starts with all the possibilities that are thinkable. So all possible theoretical buildings are at the very beginning of the process, and we start eliminating versions or alternatives until one final design remains. And we do that by adding more and more constraints. That's why at a certain time I thought this could be called a constraint design. It is, again, harnessing generative automata. This is a picture that I took from, that's not, the approach is not mine, but the idea of digital materials. To be able to remove options that seemed to be viable just a while ago, and when we add more and more constraint, we remove those options. We need to know how many options do we have, and this notion is crucial to even what I'm going to show about QUBU. The notion of digital materials. There are certain materials, just like Lego bricks, that have a finite number of ways they can be assembled. So it's not an infinite number of options, like a brick, which seems like it has a finite number of options. But if you look at this this picture, basically you can lay bricks one on another in an infinite number of ways, which means you don't know how many possibilities you have tried when you keep trying and trying and trying. There is still something left that you can still try. With the Lego bricks, as far as if I'm not wrong, there are 4 ways how you can assemble these 2 bricks together. And if you try 3 of them, you know that you've tried 3/4 of all the possibilities. In fact, when you are designing a building out of digital materials, elements that can be assembled in a finite number of ways, you don't have 4 options. You have billions and billions of options, and maybe you can try thousands of them, but still you know how many % of the possibilities you have tried. And this is what we actually do. With Monoceros, which is a plugin for Grasshopper that you were mentioning before, it's publicly available, and I'm still teaching it at the universities. You can design things like architecture or design, and I'm going to show you a couple of examples what has been done in Grasshopper. This is my homage to MVRDV. Their first project was called Berlin Voids, which was like a 2-dimensional section of a high-rise building where the rooms were looking like this. With Monoceros, you can do the same, but 3-dimensional. It doesn't just need to be one section of a building. It can go into the depth and create spaces like this. So basically, Monoceros is assembling small pieces in a meaningful way, so that always the 2 neighboring pieces are assembled in a meaningful way, so there are no collisions or no clashes. With Monoceros, there are different discrete assembly approaches available with different competition tools, I would say, and some of them are some of them work by adding pieces, those discrete elements, onto the aggregation that has already started. So you keep adding things. It's like a growth system, discrete growth system. I tried to simulate that with Monoceros, but this is not what Monoceros is doing. It's very different because it designs the whole thing at the same in one step at one time. So it means it's not really adding more and more pieces, which ends up with branching. It designs the whole thing. It fills the envelope, the spatial envelope, at one time. So what it does is, this is one of the examples that we made at Studio Subdigital back in 2021. This is a chandelier. And you can see that all these pieces are assembled in a meaningful way, so there is no leak of if those were pipes, they wouldn't be leaking. And the whole thing was designed in a one step. So it was not like growing and growing, just like I was showing before, but it was designed in one moment, which means that all the pieces were assembled at one moment, and they have the same priority when they were added. This is very important when you are designing something that is a little bit more complex than a chandelier. Let's say a house. You don't want to prioritize which element comes first and which comes second, because then the second would be dependent on the first one, and this is not what we do. It is the constrained design approach because at the beginning, again, it starts with a complete set of possible solutions, and it keeps removing and removing solutions that are not viable until it finds one final solution. More projects. This one was made by Tomáš, who is sitting here. Tomáš told this one as well. We were fighting a little bit with the visuality of those voxelated objects. There is literally no technical limitation so there's no reason that the results would be so cube-like. But it's the easiest approach. This one is showing that you can also create different shapes. And a couple of images of works of my students at some universities. I'm sitting here, so you don't really see the credits, but this was done at the UC Bartlett in 2021, this one as well. What I like about this picture is that it shows that you can make a really large aggregation, but you can work with multiple systems at the same time. So you see that there is some sort of a scaffolding and these square section pipes, and it somehow works together. Yeah. A couple of more images of what the students were doing with Monoceros. This was the time when we were testing how far we can push this, what sort of aesthetics we can achieve with that. We were trying to establish in what scale we would use this discrete assembly process, and whether we can design something that looks like a building and is kind of a meaningful thing. So yeah, this is a dormitory designed in some very early version of Monoceros. You see that it was during a workshop that happened online. It was still during the pandemics, I believe, or maybe just very early after, and it was in an environment. This is not Zoom or Meet call, but that it was in a game-like environment where people had their little avatars and they could walk through a maze that was also generated in Monoceros. Here I just want to show you that this playground is designed out of two different elements, and that's it. So it's just an aggregation of two pieces, and you can generate different versions, different objects out of that. These are students from Umprum, from Prague, who were one of the first users of this approach. They were designing a coast situation on urban scale, and then on individual scale, on a scale of individual buildings. I said that I will skip this, but still it took me almost half an hour to go through it. But I will try to focus on what is important. We have started a company called QUBU. It's a startup. It's been operating since last April. And we mean it really seriously with this discrete approach, and we try to address the pain points you were actually mentioning. And I will go through them as well. But we took the discrete approach onto a next level where we hope to or strive to generate buildings that are meaningful in an automatic way, so that we take the boring, repetitive work from the hands of architects and engineers and do that part of work for them automatically. What I'm showing you here is a very old presentation that we applied with this into a couple of incubators, accelerators. We approached the VC funds. We managed to get some funding, some very early funding, and we won some competitions with this. We were claiming that you were saying that it's 80% that people spend on repetitive tasks. We had numbers between 70 and 80%. We simplified it to 75%. So I'm very happy to hear that the numbers fit. And we say that the most educated and senior people who are the engineers and architects, that 75% of their time is wasted on something that is not creative. It's not using their expertise. And it's because they are iterating over different versions. So whenever there is a change, they need to manually go through the process again and again. And you see that on these examples that the projects took significantly longer than the actual building process. So, and it is because this is constantly reiterating all these things. Architects and engineers need to iterate over different stakeholders' anticipations and work with that in their projects. So what we do, what we strive to do at QUBU is accelerating the process, and basically we want to provide all the stakeholders actionable data on which they can decide in very early stages. On this graph, you see that usually designing something end to end takes certain time, and when you use the industry standard building information modeling, you go through different stages. When you switch between stages, you lose certain information or some work, you drop a little, and then you spend some time compensating over that, and so on. What we do is we are shortening each of these stages, starting with the very first, like feasibility study, and going all the way to the building plans, or maybe even maintenance digital twin. We do that by automating certain processes, those that can be automated. And also the starting level of where the project starts is higher than from scratch. So we are claiming that, that a usual residential multifamily building can be designed not within years but within weeks. Now we are a little bit more ambitious, so that it's a little bit faster even that. And we provide the stakeholders multiple versions, either for them to decide which one is the most viable, or to use that as the actual documentation. So we've got this is an old presentation. It's still valid, but we went much deeper right now. We were claiming that we've got 3 technological pillars of our solution. One we called informed space. Informed space is a common ground, a single source of truth where all the stakeholders record their anticipations. And also you can record the regulation and legislation inputs and site-specific inputs for the project. In other words, these are spatial maps where you can draw what is the building envelope limitation, where somebody really wants to build the house and where they want to have a park, or where they prefer to have 4-room apartments, or where do they prefer to have some retail. Literally, this is a 3-dimensional map where all the stakeholders can sketch their anticipations or very precisely record inputs from objective sources like the urban master plan, and so on. The second pillar would be parametric design. I will skip this one and I will explain that on much newer presentations. And the last one is the discrete assembly process, where we are assembling small pieces of building in a meaningful way automatically in a very rapid pace and evaluate the solution, whether it's a viable solution or not. And we are selecting those that go through a certain filter and deliver a small set of viable results or designs to the user, so that they can pick and select the one that works best for them. This is the end of my first of 3 presentations, and let me go to the second one that I have ready, which looks like this. This is the newest presentation that we have. We have changed the brand, we have changed the graphics, we have changed the identity a little. And this goes much deeper into the process. Just to clarify where we are now and what do we do, we already have almost all the crucial algorithms or solutions to the problems ready as prototypes. We are testing them on pilot projects, architectural projects. We are ready to collaborate with architectural offices, real estate developers, to test the approach, whether it works. It's still not in a form of a deliverable software, so you cannot really download the software, but you can get the individual tools from us, and you can start using them, or you can start collaborating with us on testing of what we have. So this is a little bit complex scheme of what we actually do, but I will just very briefly tell you how does it actually work. So the design process has several stages, and in each stage you solve a different problem. When you resolve the problem, then you go on to the next stage. So in the first stage, you design or set up the inputs, and you record them into the informed space, into a space where every single point in space has certain value. So there are multiple 3-dimensional maps of various things. Many stakeholders can collaboratively record their anticipations and their limits, their constraints into the informed space. In the next step, we automatically or manually find the ideal positions for building on a site based on what we already know. And we also propose what sort of typology, what type of a house can you design at those individual locations. We are currently focusing on residential buildings mainly. We propose that, and the user can then manually select whether they accept the proposal or want to use a different typology of a house. Let's say if it's a high-rise or a flat house with a hallway. In each step, we try to evaluate and score the current process, so that in every single stage there is actionable data. You know whether you're going in the right direction, whether the objectives that you have at the very beginning are met or not. Then when you have the house, you can fine-tune the house. You can decide how big it should be. We again automatically propose how big it should be. Then we try to you select something that we call the building platform, where you are saying basically this house should contain that sort of selection of apartments, single-room apartments, 4-room apartments, luxury level, economical level, and so on. You make the mix. You also can define how many of which apartments you desire to have in your house. We automatically make the apartment mix, which is a surprisingly difficult computational problem, because first of all, at first sight, it seems like it's very hard to meet the requirements for the apartment mix. But in fact, when we started programming this and using this tool, it shows up that for a typical floor, there are billions of viable solutions, and we need to score them and deliver a variety of solutions to the user, so that they can select in which direction they want to proceed. Then each apartment can be fine-tuned, it can be reassembled, readjusted. at every single point, it's being re-evaluated, so you get the numbers, you know how many of which element you have. We are also doing some computational heavy checks, like for example the solar analysis, the daylight factor, direct sunlight evaluation, and so on. The solution is based on data that either comes as a library from us, or can be designed by the users themselves, or a combination of these two. There is a template library that can be readjusted by the users. Basically, we are starting from something that we call a fragment, which I will show you later on, which is the smallest piece, discrete piece of a building. And when you put together those fragments, a building is being assembled. Again, this is based on the discrete approach, so there is the smallest adjustment that you can make. Just to give you a hint, it's either 1.5 meters or 30 centimeters. You cannot go below that. In theory, you can, but this leaves still a lot of room for the architects to make decisions. But then we generate things automatically. I will not go through this detailed image. So what I'm showing you right now, and I can go into more detail in the third presentation that I have, which most probably I will not show. But this will guide you through the different stages of the use. So what you see here is the first stage, where you're designing the informed space. Basically, you enter some objective data, like you can see them on the right side. Some of them are soft data, some of them are hard data. The hard data is the building envelope that is allowed by the municipality, where you can actually build, which is allowed. The second one would come from the real estate developer. They can brush into the space areas where they want to sell something to the individual clients. This is just an example. You can have many more, and you see the list here. The third one would be, that's a little bit more complex. When you have a point in space and you put a room into that point, how many facade walls it can actually reach. So in the corners, it can actually reach to facade walls, so it can have windows on two sides. Where there's only one wall, it can only reach one, and if the room is somewhere in the middle of the building envelope, it cannot have any window. And the last one would be the economical feasibility of selling certain type of apartments somewhere on a height level. So the bigger apartments are easier to sell on one of the top floors, and harder to sell on the bottom floors. But at the same time, it's easier to design them on the bottom floors. So this is an economical feasibility of putting a certain type of apartment somewhere. What you see on the animation in the middle is an extrapolated new data that we can read from the informed space, which means that when we put these inputs together, we can come up with new information that wasn't available before. In this case, we are claiming that these are the best positions for apartments with families, because it meets all the requirements that we have listed on the right side. And this gives us a certain map of probabilities or viabilities or weights of certain features to be distributed over the space. This is a pre-information for the solution that we then automatically generate. And we generate many of these maps so that we have better ideas for better ways of selecting out of those billions and billions solutions that are theoretically possible with recombining all the fragments together. Another thing which comes from a different project that we made, but this is implemented in the software as well. This is finding the best positions of multiple houses on a single site. You see that it works on the swarm principle, and on this one I can demonstrate that we have in each stage, whenever we are solving some sort of a problem, we are trying to find multiple ways of solving and multiple solutions. For this specific problem, we are using 2, maybe 3 different algorithms depending on the project that is being processed. This one is suitable for very small houses, and then we have another process for a large house that is being designed at one place. This is the most crucial part of our approach. We are basically splitting the house into something that we call fragments. And let me see if I have an image for that here. Yeah. So I will come back to that previous slide, but here I can demonstrate it much better. We have a sample house. This is something that that is designed either by ourselves or by the user, and then we literally chop the house into pieces. And the pieces have the same dimension. They are elements of space rather than semantic elements. So when we say that our approach is modular, by that we don't mean that it's based on some prefab elements, but it's based on spatial modules that we call fragments. It's literally a torn out piece of a building that contains some information about the building. And when you put these together in a database, in a collection, then we claim that you can recombine them and basically design almost any building out of those elements. When I say almost, of course, there are certain limitations, but we are also working on overcoming those limitations. But still, the possible recombinations here, they are unimaginable numbers. They are huge numbers of different buildings that you can build. Also, what you're looking at is an abstract view of such fragments. They have different shapes, like it's a straight wall or a T-shaped wall or an L-shaped wall with a part of a window, and so on. We literally chop the house into pieces and then reassemble them so that it actually meets all the requirements that were recorded in the previous stages. You can also zoom in and look at the apartment itself, which is the basic element. That this is the reason why somebody is designing or building an apartment house, because they want to sell the individual apartments to individual clients. And on this level, you can reshuffle and recombine these fragments to actually micro-adjust each one of the apartments. This is done. This is an animation of our approach. At this point, we are similar to what Monoceros used to be. You select one of the fragments that you want to replace with a different fragment, and the rest of the apartment changes accordingly, because that's the only option that would be viable when you change something. So the original flat facade is changed into something else, and this is under full control of the user, and this can be done at various stages of the design. We also have, not sure if this presentation is actually showing that, no, not really, but we also have, it was here, yeah. You can see it on these small animations here. Because we know how many combinations are possible from our fragments, we can generate all possible apartments, let the user to select those apartments that are suitable for that individual project, and then we can recombine and position those apartments onto different floors. You can either mix the whole building at the same time so that you achieve the suitable apartment mix. You can have the lighting conditions checked in real time. You can recombine the building floor by floor. It doesn't matter on which floor you start. You can start from the top floor, where the apartment mix would be different than on the floors below, and so on. But basically, this is the moment where we are trying to narrow down the number of solutions that the recombination actually allows. And when we are at this phase, it is then possible to identify the repeating elements that you can find within the building. And you were mentioning that term as well, but we claim that our single source of truth is the database of the fragments that we have. And that database can be designed by ourselves or by the users, and we record everything that we know about that piece of a building into that individual fragment. And there is a lot of data that you don't need to compute from the whole building. You know them up front. You know how many square meters of a room you have. You know how much material you have there. But you also know certain things that are process-based. So basically you know that if you place certain fragments somewhere, you need to perform certain check or computation. For example, you need to measure how much sunlight do you have in that room, because that fragment knows I need to be evaluated. You know that you need to check the structural integrity. You also know that each fragment needs to have something below, above, on all the other sides, and this is secured by the constrained design approach. I'm going too much into detail and also running out of time. So at this point, I would like to thank you. If you're interested in more, I can then show you another presentation where we have a step-by-step workflow through our system. And I would be very happy to answer your questions. Thank you.
Thank you for a great presentation. It's really interesting, and you pushed it forward since the last time I checked. It's really nice. I wanted to ask for the typologies. You mentioned that you choose the typologies. Do you have any sort of outcome how to get to the new typologies in any case? Like this may be sometimes the afraidness of architects to not be able to be stuck in some sort of optimization with certain finite number of typologies.
We are tackling a very, very complex problem here, and we decided that we are going to resolve it by narrowing down the slice of the problem that we are solving at the moment. So we are now trying to cover the most basic typologies. Those will be approachable by our software, but there still needs to be a way how to introduce new typologies. There are certain limitations, but it's possible. The biggest limitation that we have right now is we need to deliver design tools for the users to actually create the database of assets. So the typology is also part of the database that we have. It's possible to design something new, but we need to work on the design tools for creating the database. But technically it's possible. We are thinking about how to make this easy and simple for the users. Our current approach is that instead of starting with again, empty file, we let the user pick a template where to start, because the whole solution is kind of dependent on having the right data and the right parameters and settings. And if we start from scratch, it may be hard for the user to set up things correctly on the level that it actually does something. So it's so easy to break that maybe it doesn't give any solution. But if you start from a template, it immediately gives you a solution, and you can micro-adjust that template or keep continuously adjusting that template. When something breaks, you know exactly when it breaks, and you can go a step back. For us, it doesn't break very often because we know exactly what to do. Right now we are in the process of designing the environment, the user interface of the software, the concepts that the users need to learn so that they can start using it, but we are trying really hard to make it simple for the users. Therefore, they're starting with an example or a rough version of what they want to design, and they can slowly redesign it to something that they want. Maybe if they go far enough, then they maybe create a completely new typology. In fact, the choice of typology, it doesn't mean that it switches to a different software. It's just different data, and you can slowly adjust one typology as a straight line house into something that is a U-shaped house step by step, or you can start with a U-shaped house, and it's still the same software, the same approach.
Thank you.
Hello. For me, it was very interesting. I would like to ask, it remind me a little bit Mid-Journey. Did you think about to combine it with artificial intelligence to push it a little bit further in this way?
That's a very suitable question. It's really on spot. From the very beginning, they are comparing our approach to either the generative AI or collaborative tools like Figma. That's the software that I'm using for the presentation, but where multiple users can design the same thing. Both of these things, we are striving to be something like that, but mainly when it comes to the usability. When it comes to the AI, it's very technically and theoretically speaking, many things fall into the category of AI. So what we are doing technically is AI, but it's a different AI than Mid-Journey or Stable Diffusion or GPT. It's a different. It's not a neural network, but it is a self-learning system. Combining it, we took a different approach than using generative AI. We've got a couple of reasons for that. One is that you have very little control over the neural networks, and you have no way of knowing whether what it generates for you is actually valid or not. It's like a simulacrum of what it should be. So when Mid-Journey creates an image, you can easily have a hand with 6 fingers and it doesn't know. Then they need to spend a couple of months to fix that specific problem and teach Mid-Journey not to make 6 fingers on one hand. We took a different approach. We cannot really afford making these sort of mistakes. We need to be a reliable partner for the users, and they need to know that what we are proposing makes sense. So instead of using AI or neural networks, whenever it's possible, we come up with an analytic solution. So any problem that we tackle, we try to find an algorithm that knows exactly what it is doing. On top of that, we also try to find all possible solutions. I was demonstrating that on the apartment mix. You can start looking for a suitable apartment mix, distribution of apartments, and stop whenever you find something that is within your limits. And stop there. But you don't know if that's the best solution possible. Instead, all the algorithms that we have, they test all the solutions. They find all possible solutions, even if they are billions or trillions. We need to then narrow down the number of solutions. We have various approaches to that, and some of them use the AI or neural networks. So we use these approaches to narrow down the multitude of options that we deliver to the user. This is also quite good because we can train the neural networks on the wide range of data so that it knows very early on in the algorithm whether some way of development is actually a dead end, and it can kill that path very early, and we then don't need to generate millions or billions of invalid solutions, because we are generating all the solutions, even the invalid solutions, because we need to test all of them so that we know that how many % of those are viable or not. This is where we introduce and implement the AI. To make sure that whatever we deliver is reliable.
Thank you very much. As I understand, certain processes has to be under the control and it's better by algorithm. But is there any which you would keep open for AI, for instance, dividing of facade or colorful or something, and then narrow your options and then put it into the algorithms? Or you want everything under the control by algorithms for the future?
Mm-hmm. Interesting, and I don't know. It's an interesting idea. Thank you for the idea. I will answer more general and then I will try to elaborate on your idea. Right now, for each stage, we have basically 5 or 6 stages of the design process. For each stage, we are designing algorithms that can be automated. So you can run the whole process completely automatically from starting for setting the inputs until you have the actual plans for a building that can be built, that it can be automated in about 6 stages. But at the same time, we are making sure that a human being can interfere with those stages. So everything that can be automated can be also done completely manually without using any algorithms within the same method of creation. Or you can combine, so you can start manually, then let the algorithm to finish what you have started, or run the algorithm and then readjust manually. We are making sure that the architects are under control, engineers as well. And we provide reports and data in very early stages. With your idea, I have to think about it a little, but I can imagine that instead of manually interfering with the algorithms by humans, maybe some AI could do that as well and evaluate the results, just like a human being would look at the rendering preview and decide whether this is beautiful or not. Maybe we can plug in some AI instead of the human being, but still we have the algorithms, at least for measuring the results. But thank you for the idea.
Maybe I would add to that question. I see the possibility. I really like the informed space system you propose, and I wanted to ask, as you mentioned, that it may be difficult for people to actually fill this informed space with the right data. Do you think is there any possibility with for the AI to actually help to fill the data into the informed space in a way? I don't know. Midjourney fills the image, or ChatGPT answers the question?
I'm personally not a big fan of Midjourney. I know it's stunning. The images are so beautiful. I really believe that the hype would be over a year ago. It's still not completely over. It's calming down a little. It doesn't really matter where does the information come from. What I believe more in is stuff like this. So, for example, this is the third presentation that I didn't really show before. There are several layers of the informed space, and this, for example, is the proximity of the main road, which is somewhere here. Or I can show another one, the distance of the public transportation stops, how difficult it is to reach a public transportation stop. And these are things that you can read from publicly accessible APIs, so you can download that information from the internet. That's where I see the automation in the informed space. When it comes to the stuff like ChatGPT, maybe you have noticed here in some of these pictures, we are actually having something like a prompt here, and there was a bigger one here. So what not only we can imagine, but something that some of our partners are already working on. They are implementing our solution so in a way that the user is entering the anticipations using natural language prompts. Then it translates those prompts into parameters, settings, or like setups for what we have. We are trying to be completely agnostic all the way throughout the system, throughout the software. We don't really want to stick to one front end or one way of interaction. There is a good reason for that, because as a software we are developing this completely independent on any host. It means it's not dependent. It's not a Grasshopper plugin. It's not a Revit plugin, but it can be used from any of these environments as a library. It can be a standalone software. It could run on a cloud, and you can access it through a website. You can have it on your mobile device. We are completely agnostic. That means it allows us to embed this anywhere. We are designing our own front-end user interface that is the most suitable for the approach. Actually, there are 3 different front ends for this, but that's too much detail. But to be this agnostic, we need to create the algorithms in a very abstract form so that we can plug it to something else.
Thank you for the presentation. I have actually many questions, so I try to just ask few. What is the idea of end product? Is it kind of a black box that user would rely on data you are collecting, on decision way you already find out are the best by some rules, or is it open? Are you imagining it will be open for a user to change? Because for me it's crucial how one of the crucial way what I think is how you, for example, how you decide the order of elimination. It has different output. All the parameters can have same value, but if you change the order, it's a different thing. So that's my first question. What is kind of end product vision? Whether and the second one, or the light, maybe later. So we'll just try to answer this one.
Yeah, that's why we are looking for industry partners right now to make these decisions. We are developing software. We will make those decisions ourselves at one point, but the more inputs we have, the better the decision can be made. To answer specifically your question, how to prioritize certain aspects of elimination of versions that are not viable, this is all about the requirements of the user. Right now, we decided for some order. We call those things pipelines. We have different pipelines. The software has different modules, and the modules are plugged one after another in certain order that we selected. But with the industry partners now, we are reshuffling the pipeline, reprioritizing certain things. This is the current state. Eventually, I believe that we will come with a very simple with a software very simple to be used, simply use software, and those pipelines will be baked there or just ready-made, but still in some advanced mode the user should be able to reprioritize or reshuffle the pipelines. The only question is how much of an insider we want the user to be. How much we need to teach the user so that they can fine-tune the software. In fact, what I really expect to happen is that with the big business partners, like in the B2B relationship, we will fine-tune the product for the needs of the big user partner, specifically for each architectural studio, for each real estate developer. Maybe in each country it will work slightly different. The core will remain the same. The order of things and priorities will reshuffle. That also opens the question of who owns the data, which you haven't asked, but this is something that we think about. I asked you the question. The thing is that this allows the user to build up their own library of elements that they use across multiple projects. That data belongs to the user, but at the same time we provide the general user some generic data that either can be used out of the box or can be used to fine-tune and to create their own individual libraries. We are not collecting data from the users, from the premium users, enterprise users. We don't know, maybe we will do that for individual or free users so that we can build a bigger database. At the current point, the owner of the data is the user, but we also generate a library for every user to be used.
Oh, thank you. One more question out of those many, which is very interesting for me. When you said that the algorithm decides that this is the end dead end and it eliminates it, but from my experience, many unexpected solution starts with that end. How do you think how to incorporate it, or not? It's simple and not at the moment, not to.
I would slightly argue against what you were saying about that end to be a good start, because at a certain
not good one, but unexpected.
Yeah.
Sometimes.
Yeah. So when you are in a certain stage and performing certain task, which is a top-down approach, you know that right now I'm just distributing apartments on the floor. We know exactly how many possibilities there are, and we are testing all of them. So if we eliminate some options, we know that those couldn't go any further, but we keep all the ones that can. So within that stage, within that problem that you're solving at the moment, when we eliminate something, that we are sure that there is no way further from that point. For example, if two apartments overlap, you cannot go any further. If you want apartments to be overlapping for some reason, and maybe you can handle it somehow manually, you can still keep those solutions, and you just set the algorithm to do that. Just this specific example we are not supporting because it doesn't really make much sense to us. But technically it would be possible. And again, if you as a business client have this need, we are able to incorporate that. But in general, we are not struggling with finding a solution. We are struggling with eliminating many solutions, because we are ourselves very surprised how many solutions that are viable are still possible. Like it's billions and billions.
Yeah, it's when you put it this way, it's like clear answer. If two apartments overlap, it's sure that this is not good start, I would say. But I
can imagine.
I thought it is more kind of abstract, because I think it's really crucial in your concept. But how you make this decision of elimination? Even
we are trying to make clear what are the parameters for that. Even in the current stage of how the algorithms are approached by the user, you clearly say, this is what I want and this is what I don't want, and those are input parameters, and then it generates the solutions. And on a general level, I would say we always deliver all solutions, even if the multitude is an unimaginable number. So there is nothing left out. We are making sure that this is the approach, and maybe if we are narrowing down certain things, certain solutions, we are always letting the user know what is the approach. To be even more specific, when you have 1 billion possible combinations of apartments, we cannot deliver 1 billion to a human user, but we can maybe deliver 10. And you can say, give me 10 best solutions. They will probably look very similar. Or you can say, give me, out of the viable solutions that are not completely ruled out, give me the most diverse set of 10 solutions, so that the difference between any two elements is the biggest possible. So give me the widest the variety. And this is, I think, the best solution, because then you can, out of those 10 very different solutions, you can select 1 or 2 and then develop it deeper, and maybe you will generate different solutions that are similar to each other then, but you already narrowed down manually that number of solutions.
Thank you.
I was just thinking, you started to talk about the mid-journey. And from our experience, I mean, it's amazing, but when you try to use it as a kind of design tool, it doesn't work anymore quite easily. On the other hand, it's in the way how they implement this machine learning system, there's this point of surprise that could be really inspiring. But when you go this another way, you are probably much more in control, but how to get there, or whether from this computational way of thinking, is the possibility of the surprise there?
Yeah, that's That's a very good question, and that's also a little bit unfair question. I started with that. I started in my first presentation. What makes it interesting for me in the computational design is the emergence, or in other words, the element of surprise. We are kind of eliminating that element of surprise here. But one thing that I take as a personal challenge in the whole thing that we do here is that it shouldn't restrict the creativity. So that's why we always have the manual mode for everything, or you can decide when to actually use the automatic approach. So I can imagine, it's not really the surprise, but I can imagine that you manually design the envelope of the building, whatever crazy shape it is, and you use this tool to automatically insert apartments because that's not your creative challenge. You are challenging yourself or the assignment by creating a shape, a figure that looks the best, and then you can use this approach just to finish the work automatically and evaluate, or maybe not even finishing it. You can even distribute the spaces manually, but it gives you numeric answers. It gives you numbers. You know exactly how much of what you have, whether the sunlight works, whether the fire safety works, whether the structural engineering works. So instead of using a generative tool to surprise you, you use it so that you save your time for more important tasks. That's the biggest ambition of this approach. In a way, I can also imagine if you run it in a completely automatic mode, you will probably get something that you wouldn't design manually, but then it depends how do you optimize, what are your objectives for optimizations. If you go for very rational optimization, then most probably you wouldn't be that much surprised with the solution. But we are making sure that the solution is reliable. That if we say that this is the best solution that we found, we have really tested all of them.
Okay, so sorry to everyone. Maybe later. I am a big fan, and
Thank you.
I hope it will. You will find a solution with this like humongous effort. But I think it's very difficult to compete with pencil, which has unlimited solutions, and it's difficult to.
And it's a different approach.
It is. That was not a question actually.
Thank you then.
Thank you. I have to say I'm very impressed, really, and congratulations. It seems I'm an architect, I have used RCCAD, this kind of Revit-like software, etc. But I do research. But yeah, this it's look like it's quite disruptive. It is. Is it disruptive really? And the question is, how does it blend into the process of an architectural agency? Where does it come? Your new software before, let's say, before Revit, or before? I mean, how can this blend in the usual practice of architects, so they can adopt it and use it as another tool, or will it trash Revit at a certain point?
At a certain point, we need to be disruptive. Thank you for your question. It's on spot. At a certain point, we somehow need to have the ambition to be disruptive, but. When I was thinking about how to make my presentation here, I was thinking about how to approach the relationship with BIM, with building information modeling software. At QUBU, we are not big fans of building information modeling approach, but that doesn't mean that we go really against. At a certain point, we thought that we have an ambition to replace that. In fact, it's not completely true. if you look back when the BIM movement started, when it started to be big, like I don't know, 15 years ago, maybe that was the moment. It hasn't completely eradicated the CAD software, which is like the dumber version of that. So it still exists. People still use that. And if you look back at the CAD moment, there are still people who use the pencil. So it's an addition. It's an addition to the workflow. These tools are complementary to the existing tools. We slowly want to replace parts of things that are being made in both in CAD or like 3D drafting software and the building information modeling. We want to be the single source of truth. We need to have some connection with the BIM. We need some inputs and we need to output there, or to work with certain industry standards. We know that we are not going to replace that, but at the same time we don't want to be an enhancement of a BIM. We really want to be a standalone solution that maybe can be approached from an existing software. That's actually how we prototype things right now before we implement it into our standalone software. It lives for a while as a plugin for Grasshopper. It's a completely independent technologically, but it's accessible. We use the user interface of Grasshopper for that. I started in another presentation. This is an internal presentation that we have at the company. I see that this is being broadcast, so but yeah. I believe it's still okay. We basically have like three different levels of, or three different views or use cases of our software. The most important one is the project design, which is basically what I was demonstrating here during the presentation. It is a moment when you already have your database of building elements, the fragments, the templates, everything is ready. And you set up your own project, you select from a database. At that point, we imagine that the software doesn't even need a mouse or a drafting skills. You can work on a touch device where you're selecting from options. So that's what I was showing. But even before, somebody needs to design the assets. And some of them are going to be generic, but we don't really want to produce the same houses all over the world. We want to empower the architects to actually generate their buildings, and therefore they need to first provide some examples of how their buildings should look like. So we are also developing a set of tools for them to design the prototypes, let's call them that way. And that, I believe, will still be done in the software that architects use right now, whether it's something as simple as SketchUp or it's a BIM. It will more probably be the BIM because we also need to embed all sorts of additional advanced data into the model. So that's the workflow. That's the integration. If you want to design your own style, your assets, your settings, your geometry, your knowledge, then you will most probably use your existing BIM and somehow create the data for our software, for the QUBU software. But then you don't need that anymore. You can work with just recombining what you have already designed. And the last thing is reporting, and that's basically something that you see throughout the whole process, but this is something that I haven't really said, but as an architectural agency, you design your assets, you design the project, and send the report to your client, which could be a website link that they will click and they will see the report, see alternative versions, they will see the numbers, they will see the data based on which they can act and make decisions. So that's the workflow.
Could we imagine a disruptive idea where we can use your software to boost participation in design?
Yeah.
So instead of the architect taking the decision, it's the inhabitants or the users that are shown all the possibilities, and we like more this one, and so you can boost participation?
I'm very happy that you are mentioning this. I don't know if I can find that presentation where we show that, but we have this notion of informed space. This is something that also graphically right now, we are not there yet, but we tried to show those things in like a very excessive way so that people remember how does it look. So that's why it's this crazy shape and colors. This is something that is unique for our approach. We have the informed space, which is basically a three-dimensional map of certain values and intentions. In one of the presentations that I haven't read yet, we are showing that this is the collaborative space. This is where multiple stakeholders can enter their individual anticipations. It's collaborative. It's a social thing. It's participatory. So this is where this is the single source of truth. When we are talking about that, here you record. Everybody who is involved records what do they actually need, and then there is some probably some human orchestrator that will negotiate between those expectations. So if there are stakeholders, one of them says, okay, you only can build here, and another one says you only can build here, then somebody needs to make a decision where you can actually build. So that's why there is an orchestrator, someone, an architect, or somebody at the municipality who makes the decision, but all the inputs are inserted into one space, one place. It's recorded. We don't know exactly technically how this is going to work, but this could be some sort of a collaborative online tool where people just log in, everybody will have their own pointer, and they will see somebody else working there, like when you use the Google Docs and many people can edit the same document. So something like that. We envision that here. At the moment, we are recording the information one by one and then process that based on that. But the participatory aspect is part of the intention that we have. Thank you.